Hey everyone, today I'm going to talk about how we can use the bitwise operator in solving the DSA problems. Let's start. You are given a array A of an integer and here n is an even number. These integers must be distributed into n by 2 pair and the power of each pair is added. By power of pair ij means the XOR of two number ai and aj, and you need to write a program to determine the minimum and maximum possible sum of the power of n by 2 pairs. Here are the constraints. The size of array is between 1 and 20 and a size of array should be even and AI fits in the 32-bit integer value. To solve this question, I'm going to use the bit masking technique. So, what does this bit masking means? Suppose, as you know, an integer is a combination of 0 and 1 in its binary form. So, suppose you are given a integer x and you can take an analogy like if the ith bit of that number is 0, it means the array's ith element is consumed, and otherwise if the ith bit is 1, you can assume that the ith element of the array is available and we can use this element for pairing. Bit masking is nothing but the manipulating of each bit of a number to get the desired output. So, for this question, we are going to use the suppose n bit integer. At the beginning, all the bit of that integer should be 1. So, and as we going to pair up the element, we going to mark this bit as 0, and at the end when the our this integer becomes 0, it means this integer, all bit of that integer becomes 0, and now we can return find our answer. First, we going to find the minimum score of the array. For this purpose, I defined a function findMin, which take the long integer num and integer n and vector of integer a as a parameter and return the minimum score. This num's ith bit represent the availability of the ith element of the array. So at the beginning, first check if the number is 0, it means all the element is consumed, so return 0. And we going to use a DP to optimize our time. So it means if we already have the answer for this num, so we going to return this answer. At the beginning, the dp min will contain -1 at all the index. As we iterate over the element and finding answer, we going to update this dp min num with a non-zero value. as you assume that the score should be greater than or equal to 0, so this dp cannot be negative. So at the beginning the dp element is -1. So as we iterate over the element, we're going to update the answer. And if the dp min num is not equal to -1, it means we already find the answer for this num. So return this answer. And after this we're going to take, as we are going to find a minimum answer, so we first initialize our answer with a long max integer. So we're going to update our ans as the max. So first you need to iterate every bit of the num. So if the ith bit is available, then you're going to find the next bit which is available. So for this purpose we again iterate over the next element using the integer j. So just iterate over this, and if the jth is on, then we're going to update our answer. Ans equal to minimum of ans comma XOR of AI and AJ, and then again we're going to mask the answer. So we're going to remove the mark the ith and jth bit is as 0. How can you do this? You can do various technique, but for the simplicity I simply subtract the 2 raised to power I and 2 raised to power j from num, and then again iterate over the find min, and then at the end we get our answer, and we're going to update the dp min num with answer. So at the end we're going to return this answer. For finding the maximum score of the array, we do going to define the same kind of function find max, and which take the long num and integer n and vector of integer a as a parameter, and returns the maximum score of the array. And then as we did for the find min number, first we're going to check the num is 0. It means that it is all the element of this array is consumed, so return 0. And then next, if the dp max num is not equal to -1, it means we already find the answer for the this num, so simply return this dp max. And then we're going to initialize the our answer with a negative number. This can be -1 or -2. So as you know that score cannot be negative, so and we're going to find the maximum. So our answer initially our answer should be some negative number. So as we did for first find the on bit of the number, and then again find the next on bit of the number, and then update our answer, but this time use the max function, max of answer comma XOR of ai and aj, and then again call the function find max and num, and simple mark the ith and jth bit as 0 by simply subtracting the 2 raised to power I and 2 raised to power j from this number. And then at the end, boom, update our answer dp max num equal to ans. Here is the idea how you can invoke the find min and find max function. For this purpose, first you need the dp min and dp max vector whose size you can take is, if you want it to dynamically, you can initialize this inside the directly in the main function and pass it by using the pass by reference method, or you can just define this as a global variable of size 2 raised to power 20 and initialize its every element by -1. And same is true for this dp max. And this you can invoke this find min and find max function inside the main function, or you can define another function min and max which take two parameter and array, and here n represent the size of array. So you can invoke this find max function by passing the to n-bit integer whose every element is 1. How you can do this? By simply taking 2 raised to power n and by minus it by 1. So this will give an n-bit number whose every element is 1. And same is true for max, and at the end you will get the answer. So don't forget to practice this concept. And I pasted a link for the hacker rank question. The hacker rank question name integer distribution, and another question which I find interesting is the Leetcode 2741, the special permutation, the link here, and also I attach this link in the video description. So keep practicing, code, compete and win.